Hey there, we're going to show you a moles to grams problem now, and I wanted to give you a couple of pointers before we start. The first pointer I want to give you is one that you're going to hear a lot, and that is start with a balanced chemical equation. Now if you're in regular level chemistry, you're probably going to get the equation pre-balanced, and that's nice, and you'll get the right numbers in front of the substances that are there, and that's all great. But if you're in honors or if you're in a more advanced AP level class, watch out, because sometimes they give you the equation and it looks like everything's fine, but it hasn't been balanced. So watch out for those additional steps and make sure you're dealing with a balanced chemical equation. Alright, second thing is that once you have the balanced chemical equation, those coefficients represent the molar ratios. So now you know if substances are related like 2 to 1, 1 to 2, because those coefficients reflect the molar ratios. You also need a periodic table, because if you're going to look up masses, you really need a periodic table handy, and nobody expects you to know the masses for, hydrogen or carbon off the top of your head. Now, I might, because I'm an expert at this stuff, but you don't have to. And even still, for some of those elements, even somebody like me needs to look up stuff in the periodic table once in a while. All right, now, these kinds of problems you're going to need to use not one, but 2 conversion factors. So get ready, I'm going to show you how it's done, and I'll see you at the end of the video. Hello folks, this is a grams to moles problem. Let's check and see if this equation is balanced first before we start. Here I see that there are 4 aluminums, and on this side I have 2 times 2, which is 4. So that looks good. The aluminums are balanced. We go to the oxygens here, we got 3 times 2, which is 6, and then 2 times 3, which is also 6. So everything in this equation is balanced. Now, let's read the problem and decode it a little bit. It says, how many moles of aluminum oxide will be formed when 54 grams of aluminum reacts completely with oxygen? All right, so this is our given information. We're going to call that substance A, and what we're looking for is substance B, which is this one over here. Now, in the equation, you see that aluminum is here, and aluminum oxide is over here. All right, it's always a good idea to kind of map these things out before you begin. Now, the general plan for how we're going to solve this is as follows. We're going to start with grams of substance A. Using the periodic table, we'll convert that into moles of A, and then from there, we'll use the chemical equation to go into moles of B. And that's how we do this. So, I'm going to switch pens, and let's get started here. So 54 grams of aluminum. Dun, da, da, da. Okay, so that is a G, by the way. All right, now 54 grams of aluminum is our start, and we always start over 1. Gives us a clear idea of what should happen in the next part of the problem. So I need to go from grams to moles, and the way to do that is by getting a periodic table and looking up the molar mass of aluminum. So, I happen to have a periodic table here, of course, and you can see here that aluminum has a mass of 26.98 grams for every 1 mole. So I'm going to write that mass down here because I want grams of aluminum to cancel. So I'm going to write 26.98 grams of aluminum there, and that is the mass of 1 mole of aluminum. Okay, periodic table always tells us the mass of 1 mole. All right, so I've got that over there, so we're good there. Now, grams of aluminum are taken care of. I have to leap from moles of A to moles of B. So to do that, I'm going to look at the balanced chemical equation for that step. And I can see that the ratio, the molar ratio, of aluminum to aluminum oxide is 4 to 2. So I'm going to write 4 moles of aluminum down here and 2 moles of aluminum oxide in the top, because I want the moles of aluminum to cancel with moles of aluminum. and then I'm done. So I just need my calculator to do the rest of the calculations. So let's take a look. I'm going to multiply the tops and divide the bottoms. So 54 times 1 times 2 divided by 1 divided by 26.98 divided by 4. Again, we're multiplying the tops and dividing the bottoms. Our answer is approximately 1. So this is telling us that there's approximately 1 mole of this aluminum oxide. Now you're probably not going to need all of the decimals that are in the calculator for this particular problem. So I'm pretty sure that 1.00 is a sufficient way to report this. Of course, it's important that you write moles, almost forgot that. So it's 1.00 moles of aluminum oxide. Very important that you write the units along with the problem. So don't forget that. All right. That's all I have for now. And if you need to watch the video again, please do so and follow the process. Focus on the process, and I would even resolve the problem so that way you get used to the process and get used to decoding the problem and setting up all of the correct conversion factors that go into solving this one. That's it for now. I will see you next time. Hey, wasn't that awesome? All right, well, maybe it wasn't awesome, but at least you now understand a little bit more chemistry than you did before. All right, so a couple of key points to keep in mind for all of these stoichiometry problems. First, you always have to start with a balanced chemical equation. That's a must. You can't go anywhere without it, because otherwise your conversion factors get all screwed up, and then you get wrong answers, and then wrong answers don't make you happy. All right. Second thing that you have to keep in mind is that along the way you might feel confident, and that's good. I want you to feel more confident. But I want you to keep practicing as well. I don't want you to stop just because you were able to solve one problem correctly. You need to keep going and practice a few problems until it's like tying your shoelaces. You know this backwards and forwards. All right, and then the final thing I want you to keep in mind is that if you're running into trouble, always make sure that you're labeling your units along the way. So that way, if there is a problem and you don't get the right answer, at least you can backtrack and kind of problem solve and figure out what step might have gone wrong. All right, that's it for now. Remember, watch another video, get good at chemistry, and I'll see you soon.